We're covering one of the biggest unit traps on the FE exam, the confusion between pound mass and pound force in the US Customary system, and the critical role of the gravitational conversion factor, GC. In the SI system, things are straightforward. Mass is in kilograms, and force is in newtons. Newton's second law, F equals ma, works perfectly. 1 newton of force accelerates 1 kilogram of mass at 1 meter per second squared. There are no hidden conversion factors. The trouble starts when we switch to US customary units. The word pound is used for both mass, abbreviated as lbm, and force, abbreviated as lbf. This is the primary source of confusion. A pound mass, lbm, is a unit of mass, representing a quantity of matter. A pound force, lbf, is defined as the force required to accelerate 1 pound mass at the standard gravitational acceleration, which is 32.174 feet per second squared. This definition itself introduces the need for a conversion factor to make our equations dimensionally consistent. That factor is the gravitational constant GC, which is equal to 32.174 lbm feet per lbf second. You can find this constant in the unit conversion section of your NCEES FE Reference Handbook. So when using Newton's second law in USCS units, the equation becomes F equals NA divided by GC. Let's take an exam-style example. What force in lbf is required to accelerate a 50 lbm block at a rate of 10 feet per second squared? You can't just multiply 50 by 10. You must apply the formula. Force equals 50 lbm times 10 feet per second, divided by 32.174 lbm feet divided by lbf second. The lbm and s squared units cancel out, leaving you with the correct answer in lbf. Another major trap is the concept of weight. Weight is a force, specifically the force of gravity on a mass. In USCS, weight in lbf equals mass in lbm times local gravity g, all divided by GC. On Earth's surface, G is about 32.174 feet per second, the same numerical value as GC. This means that a 150 lbm person has a weight of 150 lbf on Earth, because G and GC cancel each other out numerically. The exam will test this by giving you a problem on a different planet with a different G, or in a dynamic system where acceleration is not equal to G. This concept is critical in dynamics, fluid mechanics, and thermodynamics. For example, the formula for kinetic energy is 1/2 mv squared. If you're given mass in lbm and velocity in feet per second, the result is not in the standard energy unit of feet lbf. You must divide by GC. The correct formula is Ke equals mv squared divided by 2gc. The same applies to potential energy. Pe equals mgh divided by gc. The slug is another USCS unit of mass, specifically designed to avoid this issue. 1 lbf accelerates 1 slug at 1 feet per second squared. This means 1 slug is equivalent to 32.174 lbm. While you should know what a slug is, most exam traps focus on the lbm, lbf, and GC relationship. Here's a mnemonic to remember. If lbm and feet per second squared are in the game, you must divide by GC to play the force game. This mental check will save you from making easy-to-miss unit errors on fundamental equations. For free practice questions, AI-powered explanations, and more exam prep tools, visit openexamprep.com. That's openexamprep, all one word, .com.